Let's spend this section setting up our server for PXE base installation. So we'll need to have a TFTP server as well as a DHCP server. Let's get a copy of our notes open. And we're now connected to the Deb6x instance. And this will be a PXE base installation or pre-execution boot environment, which means we can boot across the wire. So PXE based installation. Now this doesn't relegate you to having to set up a mirror. You could boot using PXE and then install across the internet as we've done, let's say from mirrors.kernel.org. So that's an option that's present. Once the system has been booted, the client end system or systems have been booted, you can then determine where to pull the Debian packages in from. If you have an internal mirror, then you can specify the internal mirror. If you have all the ISO images, you can collapse them or converge them into one tree that resembles a mirror with all the appropriate packages, generate a packages.gz file, and then point to that location. We'll just use the internet resource. But there are a number of things that are required. Now, of course, features include entirely net-based installation. This means no local media necessary, neither USB, CD, DVD, etc. So that's the primary feature. Of course, it means your client must support a PXE base boot environment, which most clients do via the BIOS. So enabled via client BIOS. So with that said, we have some tasks that we need to carry out. One is to confirm the server's environment. Now this again is not the server that provides the Debian packages, but rather the server that provides the PXE boot environment, which the client will use to boot, present a menu, and then get Debian bootstrapped to the point where we can select a packages repository. So first task, confirm TFTP and DHCP server configuration. Now the DHCP and TFTP servers may be one and the same, or they may also be separate systems. In our case, they're separate systems. Let's begin with TFTP. This local Debian server is a TFTP server. TFTP binds to UDP port 69. So if we stretch this out a bit and netstat, it's currently running, it's an inetd controlled service, netstat NUL, to list UDP ports, grep port 69, you'll see that it's listening. And if we grep TFTP from etc inetd.conf, you'll see that TFTP is uncommented. It runs the TCPD service with a parameter of in.tftpd, and it guards the served TFTP directory. So this tells us that this is the key directory where the content should be. So TFTP is inetd controlled and serves content from the following directory: serve TFTP. On other distributions, it might be /TFTP boot, for example. Or if you've updated your Debian server to use a more traditional directory such as /TFTP boot, then that's a directory where you'll need to place content. So our TFTP server is running. However, there is no content currently, PXE related content that is currently in that directory. So we need to get that content. And that content can be pulled from any of the mirrors online. So our next task is to, it's really a subtask, download netboot.tar.gz file and extract on TFTP server. Any mirror contains this file. So for example, let's take a look at the shell. We'll cat etc app sources.list, and currently we point to the following mirror, mirrors.kernel.org. So if we launch this mirror in a browser, it'll take us to Debian, and then we can navigate into Squeeze, and you'll see the structure that contains beneath main the appropriate directory. And once there, in fact, we could even use LFTP. Let's LFTP http mirrors kernel.org. And once there, we'll navigate into Debian. And then once there, we'll navigate into distributions, followed by Squeeze. which is the current stable. So stable is also symlink. And once within squeeze, we know that we've got main, contrib, and non-free, as we've mentioned. Beneath the main structure, there's a directory for your platform with a prefix of installer hyphen. So let's change into installer hyphen i386 for this particular client that we've set up. If using a different distro, such as IE64, then just change into that directory. Once in the installation directory for your platform, navigate into current, then images, which is the only directory currently, and then netboot. This is the full path to the file that's of interest to us, netboot.tar.gz. This PXE-Linux.0 file will be referenced by the DHCP server. So the client will be sent to load this file, PXE-Linux.0, which is a standard file that's referenced by PXE-based clients, which will then cause the client to request additional files via TFTP to help set up the grub environment, which will then boot the installer and give us the option to specify package repositories. So that's the file that we want. So since we're here, might as well get it. So instead of using wget, let's just mget netboot.tar.gz. And so long as we can write to our local directory, this will download momentarily. And this should be done quite soon. It's 8.4 megs. Now, once this is completed, we'll extract it in the TFTP directory beneath serve. So the full path, by the way, let's just copy and paste this. If you're following along for the i386 platform, is the following. So download it from the following: mirrors.kernel.org, and it's in the netboot directory, and the name of the file is netboot.tar.gz. So if you pass this string into a client such as curl or wget, it will download it directly for you. So as an example, wget and the following file will pull it in appropriately. Now the next step for us is to extract. So we want to tar xzvf extract wherever this file is currently stored. So let's see where we are, and that is local pwd. So we're in our home directory, so that's going to be simply the home of the user Linux CBT, netboot tar.gz. But this is to be performed from the serve TFTP directory. So this should really be two commands: change into serve TFTP. If that's successful, then extract the contents. Now, of course, we need to have privileges to be able to do this, so we'll su in. Let's drop the shell, su in, unless, of course, the permissions on the directory has been altered. So now notice it's extracted the content to the directory. PXE-Linux 0 points to a subdirectory, platform PXE-Linux 0. PXE-Linux config is a file that is also a pointer beneath the current structure. And notice it references a full directory. Let's just ls pxe config, and that's the default entry, which can be manipulated accordingly, and it just presents a menu, a VESA menu, colorization, and so on with some default settings. So this is what's required on the TFTP server, the extraction of the netboot.tar.gz file. So that's in place. But DHCP is what the client will make initially as a request. So the DHCP server needs to send the client to the TFTP server. On this network, currently, the DHCP server is a Cisco router. So 3, confirm DHCP server configuration. So let's just update this to reflect initially that we've confirmed the TFTP server configuration. And that's confirmed. Now to confirm the DHCP server, we will SSH as the user Linux CBT to the default gateway 75.1, which is a Cisco router. It's a DHCP server. We can even turn on debugging to see the requests coming in from the client if we'd like. So let's drop root privileges and SSH to default gateway. We know it's a default gateway because netstat.rn will show the default route. All traffic not matching the lone route of 75.0 should be sent to 75.1. This will connect us to the router momentarily, and once on, we'll be able to take a look at the configuration. Let's just confirm our password. That's correct. So now we're on the router. Now there are a few key directives, or a couple key directives that are of interest to us. One is the boot file reference in the DHCP section. So there should be a directive which reads boot file PXE Linux.0, and the other is the next-server directive, which tells the client to reference the next or TFTP server via the next-server directive. So if we do a show run and include, which is equivalent to grep, boot file, we should see a directive come back of PXE Linux.0 momentarily. And let's show run include next server, we should see 192.168.75.101, which is the IP address of the TFTP server. So these two are in place. This server is functioning as a DHCP server. Again, if we were to look at the configuration manually, one page full at a time, scrolling through, we should see momentarily the DHCP pool configuration. This is the pool configuration, which includes boot file, next server. So any PXE client on our network that has access to this subnet from a layer 2 perspective will be sent, if their PXE client truly enabled PXE via their BIOS, will be sent to the TFTP server 75101 and will be instructed to reference the boot file PXE Linux.0, which means in our environment, any client who boots up with PXE will see a default Debian menu, which may or may not be a good thing. So that's the case. That's in place. We need not change it. We'll just write mem anyway, but it's been the case. We haven't had to change it since several revisions of LCBT. So that's in place. And what is left for us to do at this stage is to boot our client, ensure that it uses PXE, and try to boot from the network, and then perform the Debian 6x installation. And just like that, it's booted up, and we have the ability to boot this particular OS. Again, it's set to PXE boot by default. That's why it came up so quickly. If we were to reboot and take a look at the BIOS using Control-Alt-Delete, and now we're in the BIOS, just had to be rather quicker. And now we see that things are set up. Now notice that we have the system time set to 1740. It's actually GMT time, which is good because when you set up an operating system, it often asks whether or not you have your settings based on GMT time, which is usually good for offsetting values appropriately. So that's in place. So we're using GMT time. That's something you should do on your systems as well, regardless of operating system, Windows, Linux, FreeBSD, you name it. So with that said, standard Phoenix BIOS, nothing fancy here. It has a gig of memory, and it is ready to be set up. We've provisioned, in this case, just 10 gigs for the installation. Again, it's running VMware. So with that said, we can exit and continue booting. It's going to use PXE. In terms of the boot process, the boot order, here we see the hard drive, removable, network boot, and so on. Now, if no drives are detected, then it'll attempt to boot from a removable device. If you'd like PXE to be first, for example, you can make changes to the environment. And let's go ahead and exit, saving the changes. And here is the boot environment. So at this stage, there are advanced options, such as the ability to enter rescue mode in the event that you are attempting to rescue your system. So you can use the PXE boot, for example, in the event, let's say you've upgraded your kernel and there is trouble booting the system, then you can use the PXE boot to rescue, at least mount your root file system and undo any damage that's been done. Also, you can use it for automated installation. You can pick a different desktop if you'd like, one of the others that are supported, such as KDE and XFC and so on. You can perform an expert installation, which provides additional options, and there's help built in. And as we navigate to install, now it's adjusted the resolution, and it's in text mode. Pick a language, scroll through the settings. DHCP has been configured, and let's name the host Deb6x, for example, with a suffix that resembles our internal domain, LCBT.internal. And this will attempt to find a mirror, a Debian archive mirror. Here are references to mirrors online. Of course, it makes sense for you to indicate a mirror that is close to you and also fast. We've been using so far, with great success, the kernel website. We don't need a proxy to get out, but some environments do, so specify accordingly. And this is now connecting across the wire to kernel.org. Now, just as we've done before, we'll time-lapse this installation as well, because the packages will be pulled across the wire, which can be rather slow. The initial set of packages are pulled in rather quickly, as there are packages that are required to customize the environment, lay out the partitions, and proceed with the download of the remaining packages, at which point we'll time-elapse, because that's what takes the longest. And of course, the size of data needed and the time it takes is all a function of the choices you make during installation and the bandwidth available to you. So, as we've mentioned, your installation can range anywhere from a gig to 5 gigs on different platforms, from 20 megs up, but within the x86 world from a gig to about 5 gigs, depending on choices made. Again, these are the bare components necessary to install Debian on the system, which must be pulled. They're being pulled across the wire, across the net. So we'll define a root password, and it'll ask us, as usual, as any good system should, to confirm. In this case, we must specify an alternate user, an ancillary user. So LCBT user, as it's advised that a non-privileged user uses the system day-to-day and only sun or sudo in as necessary to perform functions. So for time synchronization purposes, this will attempt to sync the time of the system with any of the time servers that are available online via NTP. And using one of the pool addresses, presumably, it should be able to ascertain that information rather quickly. This is our time zone. Select the appropriate one for yours. And as mentioned, you can now define LVM and other types of partitions, such as RAID and encrypted during installation. So, partitioning method. Would you like to be guided and use the entire disk, or guide and use the entire disk with LVM or with encrypted LVM, depending on the purpose of the system? If it's a mobile machine, then perhaps you should use encrypted with LVM. Let's just go ahead with the simplest option, use entire disk. Here's our roughly 10 gig partition that we've allocated. Small partition, but we can always add later on. So we can place all files in one, especially for smaller disks like this 10 gig drive, which is all virtualized, of course. It's advised to place everything in one partition. If you have larger storage, then you should segment the key partitions, home, user var, temp, opt, as you see fit across those various partitions. So let's go ahead and all files in one partition. It's a small partition, but enough to install a full system. Now let's see what the proposal is. So the proposal is to make most of the partition / or root of type ext3, and the remaining space half a gig swap. Again, not a problem. We're out of space, but once we're up, we can provision virtually more space as necessary. So let's finish partitioning and write the changes to the disk. Notice VMware was smart enough to know that the disk was not formatted, thus did not have a master boot record, and was unable to boot, so it quickly cycled over to a bootable option, in this case PXE. So this is the point where changes will be committed to the disk permanently. So if you're unsure, you can indicate no, which is the default option in the event that you execute enter inadvertently. So let's go ahead and write the changes to the disk, and the root file system will be flagged with type ext3. We could have selected type ext4. Again, also, although we've selected a remote internet mirror, we were not restricted from indicating an internal mirror. We could have specified an other mirror or other option by simply supplying our own URL. We have, for example, the first DVD ISO image on LCBT build 1, the box we've been working on so far, upgrading from Lenny to Squeeze. We could have performed the installation from that first DVD image, which is mounted, as it contains the bulk of the packages that we need. In fact, all of the packages that we need. But in this case, just provide an easy option to pull across wire. Since we're now well connected nowadays, you should be able to, across your broadband cable DSL, or perhaps from the office, install from an internet repository rather quickly. But if you're going to roll this out in a wide scale setting, do consider setting up your own mirror or mounting the ISO images internally in your organization. You can always identify the ISO images that are of interest. Usually disk 1 covers everything you need. Disks 2 through 8 contain ancillary information or additional programs. Now, we're now at the point where we should time-lapse because it's going to take a while to pull the required packages in. Again, for this platform, i386, it's roughly up to about 40 gigs of packages, of which we need roughly a gig. So we just need a small percentage of the total package size, which is why it doesn't behoove us to set up a full mirror, nor to download all of the ISO images. So let's time-lapse this and check in accordingly. So this has made rather snappy progress, just over a couple minutes. So we've decided to check back in to see what the next stage is. Now this is the base system. We've yet to retrieve all the packages, by the way. The base system is essentially the core of the operating system, for which every Linux distribution possesses some sort of core set of packages that include, of course, the kernel and other key items, key binaries, and key libraries to get the system up and running. So the ability to partition disks, boot the OS via the kernel, detect hardware, provide you with a small subset of utilities, important utilities, CP, MV, and otherwise. So this is asking us whether we'd like to participate in any package surveys. For now, we'll say no. Perhaps once the system's up and running, we can elect otherwise. Now you need to determine the type of system that's of interest to you. So we want a graphical desktop environment with GNOME. Perhaps we'd like to have Apache. And here are the other standard LAMP-based programs: DNS, SMTP, Samba NFS, CUPS for printing, MySQL Postgres, SSH, or if you're installing on a laptop. So we'll just go ahead and pick SSH server because we always like to have shell access to our system. It's critical. Now notice the number of packages has skyrocketed to 1138, which is similar to the number of packages that we had to install for the recent upgrade from Lenny to Squeeze. So more or less, más o menos, the types of installations we perform are in the ballpark, with respect to Debian, of course, of about 1,200 packages, which again is a small subset of the almost 30,000 packages. So this is where it's going to take a while to pull in the packages that are of interest. And the times will vary considerably because it's a function of size as well as available bandwidth at any given time. So when the client, whether it's curl-based, wget-based, rsync-based, pulls in the package, a deb file, it knows the file size, and the bandwidth constrains how much of that file will be able to move across the wire at any given time, which will obviously cause the ETA to fluctuate. So it swings, and it swings considerably. Notice we were just at 40-something minutes, and we've now dipped to 25 minutes, but now we're back to 33. So these swings of 8 minutes, 10 minutes are rather considerable, but nonetheless, we've pulled in 15%, and we'll just let this elapse and pick it up a bit later. So we've elapsed. This is about wrapping up at 1138 packages. Just under 5 seconds left to go. Then it'll continue with the application of the packages in the background, showing us some indications up front as it cycles through the 1138 or so packages. And of course included is OpenOffice, which is one of the larger packages included in the distribution. That's to be expected in any graphical environment, KDE, GNOME, or otherwise. And all of this is being stuffed into 10 gigs within a virtualized container, which we can provision for extra storage at some point, if necessary. Again, the full install will take 5 gigs, so it'll give us 5 gigs to play with for logging and for general system operations. But we can always spread things out as we go along later on, such as var, opt, maybe even home. And the ideal opportunity to strip or spread those mount points out usually presents itself at the beginning of the deployment. So wherever possible, spread your mount points like home, opt, var, user before users start using your system, because then you will encounter synchronization issues. Although you could always mount the old home mount point as something else and copy accordingly, or the new mount point something else, copy over the content from single user mode, and then bring the newly provisioned, let's say, home partition, home 2, into the fold as home, decommissioning the old one by removing the content. But again, ideally up front is when you want to manipulate storage, especially important storage like home and other important mount points. So as you can see, once the packages are installed, they basically are made available, or downloaded, they're installed rather quickly, made available rather quickly, just as we saw with the upgrade from Lenny to Squeeze with the recent installation. So it's just a matter of the limiting factor being bandwidth to the internet at any given time, as is expected. And this system will come up in GUI mode unless it's unable to detect the graphical environment. But since it's VMware, it should be able to, as VMware emulates commonly supported graphics, storage, and networking interfaces. So we should be able to set the resolution to a desirable resolution and use the system as if it were on native hardware, which is why VMware has the profiles that are configured for specific distributions such as Debian Linux, Red Hat Linux, SUSE Linux, and so on, to ensure that driver support is optimal. So let's elapse this as well. And now we're nearing the end of the process. Installing grub. Checking for other OSs. And grub will be installed, of course, in the MBR. So it wants our permission to install in the MBR. Let's just go ahead and tell it yes. Let's run the update grub for us. And the installation is completed. So now the system can reboot. It will boot from the hard disk as opposed to PXE. There's our boot menu. This is recovery mode 2632, and this is the standard kernel. And there's our desktop. It's defaulted to an 800 by 600 disposition. Let's log in. And we're in at 8 by 6. And of course, this can be changed on the fly. You can alter the X configuration, change the background, you name it, as you would expect with any distro. So now we're up with a new version, and we can explore it, extend it, break it, so on and so forth. It's yet another build of the operating system as we see fit. This is the standard GNU Debian menuing environment, so this should be familiar from prior versions, including but not limited to Lenny as its GNOME. And once in, DFH, there's our storage. This installation used 3 gigs leaving 6 gigs available for us to partition accordingly, perhaps for additional swap or otherwise, maybe even some other opportunity as it may arise. Let's go ahead and clean this up. We'll remove from the panel, and that's it. We've installed it. So let's go ahead and log out for now. And we have a new Debian build up and running. Again, we've installed across the wire using a public mirror, mirrors.kernel.org/Debian, pointing to the squeeze tree. And we did so with PXE. And just to quickly recap, one of our Debian servers is running as a TFTP server, and we've extracted the netboot.tar.gz image to the TFTP root directory /serve/TFTP. The Cisco router is a DHCP server which points calling PXE clients to the Debian server for the pxelinux.0 file, which presents a menu which loads the installation environment, which then gives us the ability to point to one or more mirrors online. Once we've selected and contacted a mirror, we can then download, or the installation process then downloads the appropriate files based on the appropriate Deb packages based on the selections that are made, such as package categories such as Apache MySQL and so on. Once that's in place, the files are downloaded. The installation is rather quick. Once they're installed, system reboots, you're up and running. This has Grub version 2, and it's set for usage with various services.